Hello and welcome, everyone. Today, we're kicking off a pretty epic adventure. We're not just flipping through a textbook, we are literally unpacking the instruction manual for the universe. This is our quest for physics. So, you ready? Let's get into it.
And that's really the best way to think about it, isn't it? A journey. The source material for this whole explainer just nails it with this quote. We're setting out to explore the basic rules that run everything, from a tiny atom to a whole galaxy. It's a huge mission, for sure.
You can't go on a quest without a map. And hey, here's ours. First, we're going to gear up with the essentials. Then, we'll dive into motion and forces. After that, we'll learn the language to describe it all precisely. Then, we'll get into what matter is actually made of. And finally, we'll unlock the really big ideas: work, energy, and power.
All right, so here we go. First things first. Before we can start exploring this wild universe, we've got to pack our bags, We need to gather the right tools and figure out how to use them. This first part is all about building that solid foundation.
I mean, think about it, right? You wouldn't try to climb a mountain without learning how to use a rope and compass. Physics is exactly the same. So, what are those first essential tools that every physics adventurer needs in their backpack?
And you can see how this whole path is laid out. It's so logical. We have to start with the basics, with measurement, before we can even begin to understand motion. And we've got to get a handle on motion before we can talk about it precisely with something called kinematics. It all builds, one step on top of the other, leading to the really big picture.
So, here it is, our starter toolkit. It's about getting comfortable in the lab, knowing the safety rules, and, this is the big one, mastering measurement. Seriously, knowing how to accurately measure things like mass, length, and time. That is the absolute first skill of any physicist. This is our map and compass.
Okay, toolkit's packed, we're ready to go. Now it's time to actually start observing the world. This next phase is all about looking around and starting to understand the invisible rules that make everything, well, move.
It's a question so simple a little kid could ask it, but the answer is just incredibly deep. Why does the ball eventually stop rolling? Why does the moon keep circling the Earth without flying off into space? That's what we're digging into right now. The answers really come down to a few huge ideas. We'll look at the forces that keep things moving in a circle, which explains planets in orbit. And we'll get up close and personal with friction, which is basically the universe's brake pedal. These are the hidden forces shaping everything.
Okay, so watching things move is one thing, but to be real scientists, we need a way to describe what we're seeing with total precision. This next section is all about learning the official language of movement, and it's called kinematics.
Now, this is a really crucial idea. Does it matter which way you're going? You bet it does. A scalar just tells you how much, like your car's speed is 60 miles per hour. But a vector tells you how much and which way. 60 miles per hour, heading north. That little piece of information about direction, it changes everything.
And this is the vocabulary list for our new language. We're talking about displacement, velocity, acceleration. We learn how to look at a graph and read the story of an object's motion. And then we get the equations of motion, which let us predict the future. It's basically like having a crystal ball for anything that moves.
So we've spent all this time talking about how things move. But that kind of leads to a bigger question, doesn't it? What are these things that are moving? What is the actual stuff our world is made of?
I mean, it seems obvious, but how do you scientifically describe the difference between, say, a block of wood, a balloon full of air, and a glass of water? What are their essential qualities?
Well, one of the most powerful answers comes down to one word: density. It's all about how much stuff, or mass, you can pack into a certain amount of space. This one idea is why a huge hot air balloon floats, but a tiny little pebble sinks right to the bottom.
And once you get density, it's like a key that unlocks all these other huge concepts. It explains Archimedes' principle, the magic of buoyancy that lets a giant steel ship, which is way heavier than water, just float on the ocean. See? It's all connected.
And that brings us to the final stage of our quest, the grand finale. Everything we've learned so far, all the tools, all the observations, all the language, it's all been leading to this. This is where we unlock the ultimate secret of the universe: work, energy, and power.
So listen, in physics, work does not mean showing up to your 9 to 5. It's got a super specific definition. You only do work when you apply a force that actually makes something move. So if you push against a brick wall with all your might, sorry, you've done zero work because the wall didn't budge. But if you lift a book off a table, yep, you just did work.
And if work is the action, then energy is the ability to do it. You can think of energy as the currency of the universe. It's the capacity to do work. Without energy, absolutely nothing happens. No motion, no change, nothing. It's the engine that drives reality itself. And here's the cool part. Energy isn't just one thing. It wears a bunch of different hats. This chart just shows a few: potential, kinetic, thermal, chemical. But the most amazing thing is that energy can transform from one type to another, constantly flowing and changing all around us.
And finally, we have power. Look, having a lot of energy is one thing, but power is all about how fast you can use it. A car engine and a lawnmower engine can both get a job done, right? But the car engine is way more powerful because it can do that same work much, much faster.
And do you see how it all just clicks together? It's beautiful. We started with something as simple as measurement. That let us describe motion. Describing motion led us to the forces behind it. And understanding forces took us right to the doorstep of work and energy. Every single concept builds on the one before it. And of course, the journey wraps up with a review to make sure all these ideas really stick. We even touch on deeper concepts like viscosity, which is just a fancy way of talking about how thick a liquid is. It's all about making sure you're geared up for whatever adventure comes next.
So there you have it, a whole quest, from the simple act of measuring a line, all the way to understanding the energy that powers the entire cosmos. It gives you a framework to explain pretty much everything, from why an apple falls from a tree to why galaxies spin. So the only real question left is, now that you have the tools, what part of the universe will you go question next?